because you've learned this before. So anyone remember what these graphs are called? They are, wait, Jalen, you should be over in that group over there, please. You move to your group, please. And leave those notes there because you have different notes. Huh? You what? That's fine. You can just leave them there. Yeah. Okay. Alrighty. So what are these graphs called? Braden, go ahead and bring your headphones up. Earbuds. It doesn't matter. We shouldn't have them in. We know that. That's old news. Headphones should be out. All right. Okay. What's this graph called? Anyone remember? Starts with a Q. Quadratic. These are quadratics, and they want us to write the equation for each of these. So I'm calling them polynomials because the first three are quadratics, but after that we have something else. We'll get to that in a second, okay? So we're going to write the equation of the quadratics, and all that we need is we need to know what the x-intercepts are. So can somebody tell me what those... All right, so we have two x-intercepts. We got 3, we got -4. So if we have 3 and -4, does anyone remember how to write them in the factored form? How do you put it in parentheses? No, that's writing a point. How do you put it in the factored form? So if the answer is -4, what would have been in your parentheses to get that answer? Or if your answer was +3, what was in the parentheses to get that answer? It would have been x plus something or x minus something. What? So over here, but it would have been the opposite sign, right? So this, to get +3, it would have been x minus 3. That's how you get a +3. Over here, to get a -4 as an answer, you would have had x plus 4. That would have been your factors. All right, and then if this graph, if the arrows are opening up like this graph would have been a positive coefficient. All right. Do you need to bring me your phone, Matthew? Thank you. All right, so let's double check this on Desmos just to make sure we believe it. No, you can just bring it up here. Looks like, let me get out of this. I can just put it on my desk. So if we look on Desmos real quick, if I got y equals x plus 4, x minus 3, oops, then you can see that we have those exact same x-intercepts that we just had. And we have that overall parabola shape. Okay? Everyone feel good about that equation we just got? Does that make sense? So we're going to write y equals x plus 4, x minus 3. And we're actually going to write these equations and we're going to leave them in the factored form. So for today, this is a valid form of the equation. You can also FOIL it out. You can multiply it out, and then it would leave it in standard form. But we're going to write them out. We're going to leave them in the factored form. Thank you. Hold on one second. Chance, will you grab the notes off that table? Because I don't think I left an extra sheet of notes for you. And you're going to have to erase Jalen's name off of it. Sorry about that. Okay. So over here, what are the x-intercepts you guys can see so that we can write this equation? We can see -5 and we can see 0. So for -5, I'm going to be writing x plus 5. For 0, you could write x plus 0, you could write x minus 0, or you could just write x. It doesn't matter. So you could write x plus 0, or x minus 0, or x. It doesn't matter. All of those are going to give you the same graph. So which one of these would you guys like to use in the equation? X. You guys want to use just x? So we're going to say y equals a plane x, because most people would write that first, the plane x, and then we'll write the x plus 5. And does everyone see how this graph is upside down? So since it's upside down, we're going to put a negative in the front. And if we want to double check this on Desmos, just to make sure we got it right, we can say y equals -x times x plus 5. And there's our graph. We can make sure it has the same x-intercepts. Okay, let's try the next one. So what do you guys see about this one? What's the x-intercept here? It's the vertex, yeah. And what number is it? -6. Now, how many x-intercepts are they supposed to have? 2. Can you guys stop talking, please? Because I'm going over notes. All right. We're supposed to have 2 x-intercepts. So what this means, if you only see 1 in a quadratic, is it means that that x-intercept happened twice. It means that that answer for the vertex, that answer would have happened twice. So it wouldn't just be x plus 6, because if we just wrote x plus 6, that wouldn't be something multiplied by itself. That wouldn't be x times x is x squared, which is how we get a quadratic. Over here, x times x is x squared. That's how we get a quadratic. Here, if I just wrote x plus 6, that's not a quadratic. So we have to have something squared to get a quadratic. So if we have the vertex is just sitting on the point right there, that's the x-intercept, we're going to say x plus 6 squared. It just means that for the equation, that same x-intercept, that same answer happened twice. And we can verify that by looking at Desmos. We can say, all right, this looks like the equation y equals x plus 6 squared. And we can type that in. I know that this should not have a negative in the front because the u goes up. It doesn't go down, it goes up. So I know that this is going to be positive. So if I check this on Desmos and I type in x plus 6 squared, then I can see, let me delete the rest of it. I can see that that matches my graph. Okay? If I were to take away the squared, it wouldn't show a quadratic anymore. Sorry, it doesn't like my extra parentheses. It wouldn't show a quadratic anymore. It would show a straight line because straight lines have x to the 1 power. So it would show a straight line with an x-intercept of -6 instead of a quadratic with an x-intercept of -6. Does that make sense, the difference? Okay? All right. So how do we feel about taking those points and writing them as parentheses? Is that pretty comfortable? Can we do that? Okay, so that's how we're going to be writing equations today. So we have some equations for quadratics, and then we're going to move on. And for the next few examples, we have 3 x-intercepts. So what is it called if you have 3 of them? You have an x multiplied by an x multiplied by an x. It's a polynomial, but it's a specific one. X times x times x, it's a trinomial, but quadratics can be trinomials. So this could be a trinomial, that's how many terms it is, but do you know what exponent it would have? X times x times x, cube. It'd be a cubic, okay? So we're gonna go back and label these. We're gonna say this one is a quadratic. Quadratic because it's x squared. This one is quadratic because it's x squared. And again, we're only not seeing an x squared in the equation because we left it in the factored form. We didn't FOIL it out. We didn't distribute the x. We didn't multiply things. So here, if we multiplied it out, we would see an x squared, but we're not actually multiplying it out. We're going to do the same thing for this one. Whenever we get our final answer, we're not going to multiply it out. But if we did, we would see that this one would be x to the third because we're going to have 3 sets of parentheses. 3 x-intercepts makes 3 sets of parentheses. So this one's going to be a cubic. It's going to be x to the third. So what x-intercepts do you guys see? -2, 0, and 5. And so how would we write those in parentheses? Just x and then x minus 5. Is everyone comfortable with us putting the one that is 0 as just a plain x? We're okay with that? So you could put x plus 0, you could put x minus 0, or you could just put an x. Alex, go ahead and close your Chromebook. Thank you. All right. Is this comfortable? Okay. Now, for us to figure out if a cubic graph is a positive or a negative, all we have to do is we have to look at the arrows, and we're going to lay our pencil down so that the arrows are connected by our pencil. So everyone lay your pencil down on the arrows. I'm connecting the arrows with my pencil. And now if a stick figure started walking along my pencil, would the stick figure be walking uphill or downhill? Uphill. So if my stick figure is walking uphill along my pencil, that means that this graph is positive because the stick figure is going up. This is a positive graph. Does that make sense? Okay, so if it's a positive graph, we're going to leave it because we don't usually put a plus sign in front of graphs. We just say that it's positive. And then when we write these, you can put the x in the middle, but people will think you're weird. People usually put the x in the front. So I'm going to put the x, and then the x plus 2, and then the x minus 5. And that's my equation. All right, how do we feel about that? Does that make sense? Okay. Let's try the next one. So go ahead, take a moment and write down what you think your parentheses should be for each of the x-intercepts. We have 3 of them again. So right next to the x-intercepts, write down what you think your parentheses should be. What should your parentheses be? Anyone want to share what they got for their parentheses? Yeah. X plus 3, x minus 1. What was the last one? Perfect. Okay, and then we're going to lay our pencil down so that the arrows are connected. And if we put a stick figure on our pencil and have him start walking, is he walking uphill or downhill? He's walking uphill, so we're going to say this is a positive equation. And so I'm going to say y equals a positive. I don't put a plus for a positive. I just don't put a negative there. X plus 3, x minus 1, x minus 4. Now, if you want to check your answer for this because you're unsure if you got it right, you can still check it in Desmos. But these ones, the grids, start to get really big really fast, okay? So left and right, it's still -8, +8 like normal. But if you look at the y values, it actually goes from -15 to +25. So the y values got really big. So if you're going to check this answer on Desmos, that's fine, but you're going to have to change your window, because if I try to graph it on a normal window, so this is what Desmos usually has, this is what Desmos usually looks like. If I try to graph that problem on here without changing my window on Desmos, if I type in x plus 3, x minus 1, x minus 4, I might think I got it wrong because I can't see as much on Desmos as I can see on my paper. So if I want to compare Desmos to the paper the exact same way, I'm going to have to change Desmos to -15 and +25, just like my paper has, and then I can compare it exactly the same way and see that, oh, the x-intercepts are the same. And now I can compare the graphs more easily. So you can still use Desmos to check your answers. You just want to, with these ones, because the numbers get really big really fast, you're going to want to change your window. Okay? And then if you want your window to go back to normal on Desmos, you just have to click the home button. Go back to normal. Okay? All right, let's do the last one. So go ahead and take a moment, write down what your parentheses should be. Okay. What do you have for your parentheses? Okay. You were right with the x minus 6. That was right. And then do you have this one right here? X. Perfect. Okay. So we've got that. And then if we connect the arrows with our pencil, is our pencil walking, or is the stick figure walking uphill or downhill? Downhill? Up? Now, the stick figure doesn't walk right to left because we're in America, right? So we always go left to right. So down. Okay, does that make sense? So whenever we do the checking, we always go from left to right. Okay? All right. Because it could be confusing. Okay? So we're going to check the way that we're walking the same way we read paper. Yeah. Yeah, no, you're exactly right. You're exactly right. That was a good clarification. So whenever we check it, we always go left to right, okay? All right, so left to right, he's going downhill. And so we're going to say we need a negative this time because we're going downhill, okay? Now, we always put the x first, and then we got an x plus 1, and then we got an x minus 6. Okay. All right, Sanders group, that's what you guys are doing. So let me go ahead and give you your assignments. All right. So we're going to keep going. You guys ready? Okay. Now, this group is still, not this group, this problem is still a cubic, but it only has one x-intercept. Can you guys tell what it is? It's 4, +4. So what should the parentheses be? X, you're close. Minus. Okay, x minus 4. I think you said plus. Did you say plus? You said minus? Okay. So x minus 4, and then you said cubed. Why did you say cubed? Yeah, it's still a cubic, and we have to make sure if it's a cubic that we have something to the third power. So we know this graph is going to be y equals x minus 4 cubed. So this is really similar to that one example we did like this. So it only had one x-intercept, but we knew that it was a quadratic graph, so we knew that that one x-intercept had to happen twice. So we had to write it. We had to say, oh, that one x-intercept happened twice. This one, we knew it was a cubic graph. So we said, okay, it only has one x-intercept, but that one x-intercept must have happened 3 times. So x minus 4 to the third power. Now, if we connect those arrows with our pencil, is the stick figure walking uphill or walking downhill? Uphill. So that's positive, so I just need to make sure I don't put a negative there. Okay, let's try the next one. So here we have this x-intercept and we have this x-intercept because we were looking at cubic graphs. All the ones we're doing right now are cubic. Yeah. But we'll see more in a second because you're onto something. Yeah, that was a good question. Okay, so this one right here, what are the parentheses going to be for this one? X plus 1. Okay. And now this one over here, it looks really similar to something else we've already done, right? So if we turn to the previous page, we can see it looks really similar to this, doesn't it? So it's going to be x minus 4 squared. Does that make sense? Okay. So we're going to go back, and we're going to say this is x minus 4 squared. Everyone see that? So the ones that go straight through, they just get a parenthesis. But the ones that look like mini parabolas sitting there, little quadratics, those ones that get a squared. And if you look at that, we can see that if I was to FOIL this out, it would be an x squared. And if I was to FOIL it with this, then I'd get an x cubed. I'd get a cubic. And so that's what makes it 3 overall. 2 from this one, 1 from that one. Okay, so now if I connect my arrows, what do I see? Positive. If my stick figure was walking, he'd be walking uphill. Okay, so I'm going to say y equals positive x plus 1, x minus 4 squared. Now, when you write your parentheses, it doesn't matter which order you write them. You'll get the same answer. If you were to graph it and put these backwards, you'll be totally fine. Okay? All right, so this leads us to a conversation about something called multiplicity. Okay, so multiplicity is this little number that is next to the parenthesis. Okay, it's multiplicity of the x-intercept. So multiplicity is how many times that x-intercept happened. This is not like a professional definition. This is not like the formal definition. This is just me doing it in like plain language. So this x-intercept happened 3 times. So it had a multiplicity of 3. You're good. So this graph, this x-intercept had a multiplicity of 3. This one went straight through. It had a multiplicity of 1. That answer just happened once. Thank you. Hold on one second, Natalie. There you go. And then, yeah, you can sit in your normal seat. And then here are the notes. You're welcome. And then this answer happened twice. So if you have one answer that happened once and one answer that happened twice, how many answers do you have? 3. And that adds up to a cubic graph. If you have one answer that happened 3 times, you have a cubic graph. Does that make sense? So cubic graphs should have 3 answers, quadratic graphs should have 2 answers. So the multiplicity is just saying how many times did that factor happen as an answer. Okay? All right. So when we look at x-intercepts on the graphs, there are other names they can be called. So zeros, that's another name for an x-intercept. Roots, that's another name for an x-intercept. So these are all the same thing. And there's 3 different ways they can be drawn. And we've seen all 3 of them already in the examples. Okay? So we can have a multiplicity of 1, which we saw for most of our examples. So they can go straight through and be slanted that way. They can go straight through and be slanted this way. They can go straight through and be almost straight up and down. But these are all a multiplicity of 1. And that was what most of the examples were doing for the previous problems. So if we look back at the previous page, these were all multiplicity of 1. That answer happened once, so it went straight through, straight through. So this answer happened once, this answer happened once. Straight through, this answer happened once, this answer happened once. This answer happened twice because it didn't go straight through the x-intercept. Do you guys see the difference in how they look? This answer happened once, once, once. Straight through, straight through, straight through. Does that make sense? Multiplicity of 2 is for answers that happened twice. So these will look like mini parabolas. They look like this. And they could be anywhere on the x-axis. So they kind of bounce. They bounce when they hit the x-axis. And that means that you have 2 answers that happened at that x-intercept. And that happened twice on the previous examples. So right here, we had a multiplicity of 2. We had that answer happen twice. And then right over here, we had a multiplicity of 2. We had that answer happen twice. Okay? So x plus 6 squared. And then on the other one, we had x minus 4 squared. So I could have typed this as y equals x plus 6 squared, but I also could have typed it as y equals x plus 6 times x plus 6. And both would have given me the same graph. It just means that answer happened twice. Does that make sense? Okay. And then the third type is a multiplicity of 3. It just means that that answer happened 3 times. And this one, it goes through, but it doesn't go straight through like a multiplicity of 1. It kind of squiggles as it goes through. So it goes up, and then it levels off a little bit as it goes through the x, and then it goes up again. So it doesn't go straight through, but it like squiggles as it goes through. Or it could go down, level off, and go down. So up, level off, go up, or down, level off, go down. That's what the multiplicity of 3 looks like. And so we had that happen on our paper 1 time. Multiplicity of 3. So that means if we typed this problem into Desmos, we could say, yep, x minus 4 to the 3rd power, or we could have said x minus 4, x minus 4, x minus 4. That same answer happened 3 times. Okay, how are your brains feeling? All right, so when we look at graphs, we're going to find the x-intercepts, and then we're going to determine if that parenthesis happened 1 time, if it happened 2 times, or if it happened 3 times. And we're going to determine that based on how the curve goes through the x-axis at that point. Does it go straight through so it's a 1? Does it bounce so it's a 2? Or does it squiggle as it goes through so it's a 3? Does that make sense? That's what we're going to do. Okay, so the first one, this example 9, I can see an x-intercept right here. And I can see an x-intercept right here. And I can see an x-intercept right there. So we got 3 x-intercepts. Okay. So our first set of parentheses are going to be x plus 3. Our next set of parentheses are going to be what? X minus 4. And what's our last set of parentheses going to be? X minus 7. Okay. Now, this one, it goes through. It doesn't bounce. Does it go straight through or does it squiggle through? It squiggles through. So this is going to be a multiplicity of 3. All right, this one goes through. Does it go straight through or does it squiggle through? Goes straight through. So this would be a multiplicity of 1. Now, you can write the 1 or you cannot write the 1. Most people don't write the 1. But once we're doing this, it's kind of nice to write it so you know you've done that one already. So it's up to you guys. You can write it or not write it. Hang on one second. Let me get finished with the examples and then yes. Okay. The next one, does it go straight through or does it squiggle through? Straight through. Okay. Now I'm going to put my pencil on the arrows. What do we notice? Positive. Okay. So I'm going to say y equals x plus 3 to the third, x minus 4, you can put the 1 or not put the 1, x minus 7. Okay. How do we feel about that? You good? Okay. Let's try the next one. Okay. So what should our first set of parentheses be? Okay, x plus 4, and then squared. Why is it a squared? Yeah, because it bounces. It stops there. It bounces. Okay. What's the next parentheses? X plus 1 cubed. Someone else tell me, why is it cubed? It squiggles. Squiggles through. Okay. And then what's the last set of parentheses? X minus 1. And then why does it not have an exponent? It goes straight through. Okay. Now, both of the arrows go up, which means it is most similar to a graph that's like this. And if it's most similar to a graph that's like that, would it be positive or negative? Because we have parabolas that look like this and parabolas that look like this. So this is the positive graph, this is the negative graph. So this would be a positive one. So we're going to say y equals the positive version, x plus 4 squared, x plus 1 to the third, and then x minus 1. Okay. Nope, you can switch up the order if you want. I usually go left to right, so that just ends up being the same order, but no, it doesn't matter. Okay, what parentheses are we getting? X plus 1, x minus 2. Any idea what the multiplicity is? 3 for which one? Yeah, which one is a multiplicity of 3? X minus 2 is a multiplicity of 3, so it squiggles as it goes through. Okay. What about the first one? What's that multiplicity? 2. Okay. And then if we put our stick figure down, or not our stick figure, if we put our pencil down, Negative, okay. Y equals negative x plus 1 squared, x minus 2 to the third, okay. Is everybody putting their y equals in the front of their equations? We all got our y equals? Okay. All right. Anyone have their last equation? Yeah.
Y equals negative x cubed x plus 3x.
Okay. We agree with that? Yep. Marvelous. Okay. So, and that's what you guys are going to be working on. Let me go ahead and hand